Welcome once more to part 14 of Alpha Found. The example in the last video demonstrates the mechanics of the perturbation risk model. It also demonstrates how a positive alpha does not necessarily mean excess risk-adjusted return. If the perturbation risk model is correct, one consequence is that expected non-zero alpha is simply a statistical artifact of using OLS as an estimation method. Now we need to go from the numerical example in the last video back to algebraic reasoning. This will take some time. It is not possible simply to watch the video and understand it. The mathematics moves too fast. I recommend you go to the associated website and download the transcript so you can study the derivations more carefully. There is no login and you will not be asked for any personal information. In this video, we will begin to derive various expected outcomes depending on the magnitude and relationship between the perturbation risks. If an index is divided into two portfolios of equal market capitalization, there are 9 scenarios or combinations of expected outcomes, assuming the average perturbations are 0, that can occur simply by having the requisite ideal systematic risk and perturbation risk parameters without altering average arithmetic returns. Let's take a look. The first 4 scenarios are contrary to the volatility effect. In scenarios 1 through 3, the expected alpha of the low CAPM beta portfolio is less than 0, which is less than the expected alpha of the high CAPM beta portfolio. And the expected Sharpe ratio of the low CAPM beta portfolio is the smallest of the Sharpe ratios. Take a moment to notice how the order and relationship between Sharpe ratios change with each scenario. The 4th scenario is CAPM with the expected alpha is equal to 0. The 5th and 6th scenarios are weakly consistent with the volatility effect. The expected alpha of the low CAPM beta portfolio is greater than 0, but the expected Sharpe ratio of the low CAPM beta portfolio is still the smallest. Note that scenario 6 is the same as line 9.17. The remaining 3 scenarios, which describe the volatility effect as commonly understood, are what is usually found in market data. Scenario 9 is the one that will eventually have our attention, where the expected Sharpe ratio of the low CAPM beta portfolio is highest. It is the average excess market return, assumed to be greater than 0, the ratio of the two perturbation risks, called the perturbation risk ratio, or PRR, and their relationship to the two ideal betas that determine the relationship between expected alphas on the one hand and expected Sharpe ratios on the other. There are several ways the following conditions and derivations could be presented. I've chosen to do it in a way that I believe is best suited for these videos, but that might not be the best way for other purposes. In a later video, it will be clear why I have chosen the way I have. Remember that we are still assuming that the average perturbation over time is 0, but not 0 in any given time period. Let's derive the condition of scenario 1. After the derivation is finished, it might take some review to understand it fully. Scenario 1 has expected alpha of the low CAPM beta portfolio less than 0, which is less than the expected alpha of the high CAPM beta portfolio. And the expected Sharpe ratio of the high CAPM beta portfolio is greater than the expected Sharpe ratio of the market, which is greater than the expected Sharpe ratio of the low CAPM beta portfolio. If the expected Sharpe ratio of the high CAPM beta portfolio is greater than the expected market Sharpe ratio, we can use the definition of the Sharpe ratio to get this expression. Using equation 12.5b, we can make a substitution. Then, by dividing through by average excess market return, we get squaring both sides, taking the reciprocal, and reversing the inequality gives Then by expanding the variance on both sides and canceling the ideal high beta squared on the left-hand side, subtracting ideal market variance from both sides, and multiplying through by 4, dividing through by perturbation risk of the high CAPM beta portfolio and subtracting 1 from both sides gives Finally, taking the reciprocal again and reversing the inequality, I want to reorganize the left-hand side for reasons that are not obvious. Substituting the right-hand term back into the previous inequality gives us this form. Taking the square root of both sides, assuming the covariance between the perturbations is 0. Using the ideal betas from example 13.1, the left-hand condition is, as a numerical example, if the standard deviation of the high perturbation is 10% and the standard deviation of the low perturbation is also 10%, then this condition is met. If condition 1 is met, then scenario 1 is expected. If we take the numbers from this quick example and plug them into the formulas of videos 12 and 13, we get, which means the expected alpha of the low CAPM beta portfolio is less than 0, which is less than the expected alpha of the high CAPM beta portfolio. And the expected Sharpe ratio of the high CAPM beta portfolio is greater than the expected Sharpe ratio of the market, which is greater than the expected Sharpe ratio of the low CAPM beta portfolio. For the same average arithmetic total returns and ideal risks as found in example 13.1, expected alphas and expected Sharpe ratios can change in magnitude and order depending on the relationship between the perturbation risks.